continuing our work with complex numbers, all right? And there's a concept I need you guys to understand is this idea of complex conjugates. So a complex conjugate, if you have a real number and you add an imaginary number, the complex conjugate of that would be that real number, whatever the real number is, minus the imaginary number, okay? These right here are considered to be complex conjugates of each other, okay? Now, we are never allowed to have imaginary numbers in the denominators. We have to change that. We got to simplify this. So I want you to understand is you're going to take the numerator and the denominator, and you are going to multiply the denominator by the complex conjugate. So if that's 7 minus 8i, this is your a value. This is your b value. Okay? Then I'm going to multiply both the numerator and the denominator by 7 plus 8i. And 7 plus 8i. Now, just so you guys know, 7 plus 8i divided by 7 plus 8i is just equal to 1. So I'm not changing the value of the number, I'm just changing the way it looks. So let's focus right here in the denominator. I'm going to show you guys the long method, then I'm going to show you a shortcut. Here we go. 7 minus 8i times 7 plus 8i. We're working clearly just in the denominator. Yes, we are going to do the FOIL method. 7 times 7 gives us a 49. 7 times a positive 8i becomes a positive 56i. A negative 8i times the 7 is a negative 56i. And a negative 8i times a positive 8i is a negative 64i squared. The whole purpose of the complex conjugate is for this reason, right here. What happens to all of the i's in the middle? They cancel out. That's the whole purpose of it. So every single time, if you find the correct complex conjugate, what's going to happen every single time to all of the i's in the middle? They go away. So all we're left with, everybody, is a 49 minus a 64i squared. But wait, what is I squared by itself always equal to? Negative 1. So look what happens when I have a 49 and I take away a 64 and I'm going to replace the I squared with a negative 1. What happens? It becomes a 49, not minus a 64, but plus a 64, which gets you to the number of 113. Notice, the number 113 doesn't have any i's, it doesn't have any I squared, it's just a rational integer, it's just a whole number. Yes, the complex conjugate gets rid of all of your imaginary numbers and makes your number a whole number. Okay?
There's a little thing you get rid of the I.
That's right. So, by the way, can I show you guys a shortcut to that? Because what does this end up becoming? This ends up becoming 113. Here's your shortcut. I'm going to write shortcut. Okay? Whatever your A value is. What was our A value? Our A value was a 7. We squared. What was our B value?
8.
Just the 8. Just the 8. Because it says what? It says A, we have to see how you have a plus BI and you have a minus BI. So the B value is just the number what? 8. Square that. Then all you got to do, everybody, is just simply add them together. And that will always give you your denominator. Not the numerator, but that will always give you your denominator. 7 squared plus 8 squared. What was 7 squared plus 8 squared in this particular case? 113. So what I want you guys to do in your journal is if you ever want to get what the complex conjugate is going to be, well, not the product, sorry, the product of the complex conjugates will always be the a value squared plus the b value squared. That's your shortcut. Okay? Now, we're not done with the problem. We're almost done. We still have to do what with the 2? We have to distribute the 2 to the 7, and we have to distribute the 2 to the 8i. So 2 times 7 is 14. 2 times 8i is 16i. Now, do you remember the final answer? What I always tell you your final answer needs to be in the form of a complex number, which is what? A plus your b, I. So here's how it works. The a value, everybody, is 14 over 113. 14 over 113. Your b value is 16i over 113. This is your final answer. This is broken down. You guys ever have a multiple choice test where they say choose the answer that's best?
Yeah.
This would be your best answer because it's technically the most
Accurate.
Yep, the most accurate. It's the most simplified. It's in the correct form of all complex numbers. If you're ever taking a college algebra class and you're having to put your answer in the form of a complex number, you better make sure you break it into a real number, right here, and what's this part called? An imaginary number. Okay? So you have your real numbers with being added or subtracted, imaginary.